All right, here we go. Okay. So today we start antiderivatives. So we were working with derivatives all semester where we would do the power rule and we would take one away. But now we're going to do antiderivatives where the power rule will now add that one back. But of course, we got to get through the notation first. So if you see this symbol, we say that is called the integral of f of x dx. That means we are going to find the antiderivative of f of x with respect to x. Okay, so when you do the integral of f of x dx, we end up with the antiderivative of capital F of x plus c. So we need that c there. That c is called the constant of integration. And if you want to check your work to see if you did the antiderivative correctly, well, all you have to do is take the derivative and it should give you back the original function that we were working with. Okay. So again, that curvy symbol is called the integral sign. The function inside is called the integrand, and the symbol dx just tells us what we are taking the antiderivative with respect to. And that c is called the constant of integration. So that c has to be added on every time. Okay, so antiderivatives. All right, so down here we have some formulas. The very first formula is your best friend. This is the power rule for antiderivatives. So this one is the power rule. So this says for x to any power of n, the power rule will become, or the antiderivative using power rule will become x to the n plus 1 over n plus 1 plus c. So again, since this is the antiderivative, we're adding that one back. Okay, so that's the power rule, and it's going to be the one of the most popular rules we use today. The second rule, well, this one's fun. The integral of e to the x is e to the x. Just like the derivative. The derivative of e to the x was e to the x. The antiderivative of e to the x is e to the x. Of course, plus c. 3, if you see an integral of this form, 1 over x, then the antiderivative will be the natural log of the absolute value of x plus c. So if you ever have 1 over x, this will always be the antiderivative, the natural log of x. We never, ever flip this to become x to the negative 1. I'll show you later on why we don't. Okay, and then 4 and 5 are just algebraic properties that we can apply to our integrals. So 4 says if there is a coefficient in front of our function, in front of our integrand, then all we have to do is move it to the outside of the integral and then find the antiderivative. Okay. 5 says if you have multiple terms inside your integral, then you can split it into multiple integrals. So this says the integral of f of x plus or minus g of x can be rewritten as the integral of f of x plus or minus g of x. And then rule number 6 is the constant rule. So this is going to be a good one. This is the constant rule for antiderivatives. So it says if you're given a constant k, and remember a constant is just a number by itself. If you're given a constant, then the antiderivative is kx plus c. That's it. Okay. All right. So let's try our examples out. Okay. All right. So number 1, we have the integral of 7dx. So this is just a constant. 7 is just a number, a constant. So this is going to use rule number 6. So the antiderivative of 7dx is going to be 7x plus c. That's it. All right. So, like I said, if you want to check your work, all you have to do is take the derivative of this answer. So what is the derivative of 7x?
1.
The derivative of 7x.
7.
It's 7. So you get back the original problem. And what is the derivative of any constant?
0.
0. So there you go. That checks our work. Okay. All right, let's keep going. Number 2, the integral of 8x dx. Okay, so what we're going to use, I think, is rule number 4 or 5, whichever allows me to rewrite it. And we're going to rewrite this by moving the 8 outside times the integral of x dx. Okay, so now we are going to use the power rule on this. This is x to the first power, and we're going to use the power rule. The most popular rule we're going to use today. So when we take the integral and find the antiderivative, we're going to get 8. And I'm going to put brackets just to be neat. You can put parentheses if you want. And we're going to use the power rule. So we're going to rewrite it as x to the 1 plus 1 over 1 plus 1. So that's the power rule. And now we will clean it up. You'll get 8 times x squared over 2. And now multiply the 8 in there. 8 divided by 2 gives me 4x squared. And don't forget to tack on the c. There you go. And again, check your work. What is the derivative of 4x squared?
8x.
Boom. We did it right. Any questions so far? All right. Let's keep moving. We got a lot of these to cover. All right. Number 3, just like the one above. The integral of 9x squared. So again, I'm going to rewrite it. Move the 9 out. Have the integral of x squared dx. And again, power rule. 9 times x to the 2 plus 1 over 2 plus 1. And you get 9 times x cubed over 3. Multiply that 9 in there. And 9 over 3 gives me 3x cubed
plus c.
Good. Plus c. Boom. There you go. Cool. All right. Not bad, right? For now. All right. Number 4. This just says find the integral of x to the 5th. So again, we use power rule. So you'll have x to the 5 plus 1 over 5 plus 1. And we get x to the 6 over 6 plus c. That's it. And that's the first page. Any questions? Everybody good?
Yes.
All right. Keep moving. Number 5. X to the negative 3. Once again, power rule. So you'll get x to the negative 3 plus 1 over negative 3 plus 1. This will give me x to the negative 2 over negative 2. Now, this is probably finished. but I can show you how to rewrite it because I hate negatives in the denominator. And we can use the negative exponent rule. I can rewrite this as -1 over 2x squared. This guy flips to the denominator, and all I do is move the negative symbol to the numerator. That's it. Only because of my hate of negatives in the denominator. But my math lab may take that, it may not. Just know how to rewrite them. Okay. 6. Do it again. Move that 10 outside. 10 times the integral of x to the 3/2 dx. And once again, guys, the most popular rule, power rule. 10 times x to the 3/2 plus 1 over 3/2 plus 1. Now a little fraction math for you, right? 3/2 plus 1, you put 1 over 1 and get a common denominator of 2. So you'd get 3/2 plus 2/2, so we'd get 5/2. So we're going to have 10 times x to the 5/2 over 5/2. Okay, now we still have some fixing. So we can't have a fraction in our denominator. So we will multiply by the reciprocal, or what students love to say is we will flip this. Now, when you flip it, the 2 will go to the numerator and the 5 will stay in the denominator. So our rewrite is going to be 10 times 2x to the 5/2 over 5. Okay. And now you'll multiply the 10 in, or we can cross cancel. 5 and 10, that becomes 1, that becomes 2. Multiply that straight across. I should probably put it better up here instead of, so you don't think it's in the denominator. Multiply it straight across, and you get 4x to the 5/2 plus c. There you go. Any questions on that one? Lots of fraction work. Don't be afraid. Okay. 7. The integral of 3 over z dz. So what I'm going to do here is take the 3 out. This is going to give me 3 times the integral of 1 over z dz. Now this, I believe, is going to use rule 3, which is the integral of 1 over dx equals the natural log of the absolute value of x plus c, because this shares the same format. 1 over x, 1 over z, they're the same, just different variables. So this means our work is easy. The integral of 1 over z dz becomes the antiderivative of 3 times the natural log of the absolute value of z plus c. That's it. All right. All good?
Yes.
Yeah. All right. All right. 8. You're going to move that 16 out, and you get 16 times the integral of e to the u du. This one is going to use property 2, I think, where it said the integral of e to the x dx is still e to the x plus c. And again, that's for e to the x. Ours is e to the u, same format, different variable. So our work is 16 e to the u plus c. There it is. Those are nice. All right. Number 9. The integral of 5x times 1 minus x. Okay, so we're going to have to algebraically fix this before we find the antiderivative. So we're going to distribute the 5x first. So we're going to get the integral of 5x minus 5x squared dx. Okay, so we distributed the 5x, and now I have 2 terms inside my integral, which means we're going to split this into 2 integrals. I'm going to have the integral of 5x dx minus the integral of 5x squared dx. So we just took it and split it into 2. Okay. And now we're going to rewrite it one more time by pulling those 5's out. So I'll get 5 times the integral of x dx minus 5 times the integral of x squared dx. We are now ready to find the antiderivative, and both of these integrals we will use power rule on. So the first one, that 5's outside, and you have x to the first. You'll get x to the 1 plus 1 over 1 plus 1 minus 5 times x to the 2 plus 1 over 2 plus 1. Clean up. 5 times x squared over 2 minus 5 times x cubed over 3. And our final answer is 5 halves x squared minus 5 thirds x cubed plus c. Wowzers. Okay. The integral of du over the square root of u. Okay, so again, we're going to have to do some fixing. So we're going to first rewrite that square root of u. I'm going to have the integral of du over u to the 1/2. And then we're going to flip it up, and I'll get u to the negative 1/2 du. Okay, we have rewritten it, and now we're ready to find the antiderivative. And guess what? We're using power rule. U to the negative 1/2 plus 1 over negative 1/2 plus 1. We're going to get, well, negative 1/2, that's negative 50 cents plus $1. So that leaves me with positive 50 cents over 50 cents. Okay. And again, you can't have that fraction in the denominator, so we will flip it. And we get 2u to the 1/2 plus c. Or it may make you rewrite it as a square root. So you could rewrite it as 2 square root u plus c. Okay. Any questions so far on those two? All right then. (11) dx over 4x cubed, the integral of dx over 4x cubed. Of course, rewrite it again. So we are going to take out the fraction of 1/4. So I'll get 1/4 times the integral of dx over x cubed. So all I did was take out the 1/4. And now you're going to flip up that x cubed and give us x to the -3 dx. Now we're ready to find the antiderivative. Power rule, of course. That 1/4 stays out there, bracket for neatness, and you get x to the -3 plus 1 over -3 plus 1. Clean up. 1/4 times x to the -2 over -2. I will multiply straight across, and you'll get x to the -2 over -8. And again, this could be a suitable answer, but I do not like negatives in my denominator. So I'm going to flip the numerator down and move the negative up, which means we're going to get -1 over 8x squared plus c. Okay, cool. Good, good, good. Is that it for this page? Yeah. All right, there's that page. Everybody good?
Yes.
All right. Okay, 12. We have the integral of 4 plus u over u du. We don't know how to take the or find the antiderivative in this form. So what we're going to do is manipulate it algebraically. So we see that I have 2 terms over the same denominator. This means I can split this into 2 separate fractions. I can make this the integral of 4 over u plus u over u du. So all I did was take the fraction and split it into 2 because they're over the same denominator. And now I'm going to simplify it. I get the integral of 4 over u, that's going to stay the same, plus u over u, which becomes 1 du. Okay, and now I have 2 terms inside the same integral. So we're going to split it into two integrals. And I'm going to get the integral of 4 over u du plus the integral of 1 du. Okay, one more rewrite. I'm going to take that 4 out, and I get the integral of 1 over u du plus the integral of 1 du. Okay. And again, we never flip a 1 over u or a 1 over x or a 1 over any variable if it's to the first power. Never flip that, because this will use that property on the first page for the natural log. Okay, so if we find the antiderivative, the first one, you're going to get 4 times the natural log of the absolute value of u, plus the second one is going to use the constant rule. The integral of 1 du becomes u plus c. All right, there it is. Leave that there. Okay. And 13. The integral of 5e to the z plus 4 dz. So what we're going to do is, again, split it up into two integrals. This time we can skip a little steps. So for 5ez, I'm going to rewrite this as 5 times the integral of e to the z dz. So I already took the 5 out. So we're saving some time here. Plus the integral of 4 dz. All right. And now, what is the antiderivative of e to the z going to be?
E to the z.
E to the z. Plus the antiderivative of 4 with respect to z. For what?
Or z plus e.
That's it. Boom. There we go. All right. Keep them moving. Okay. 14. The integral of 3x squared minus 2 over x squared. Okay. So again, split this up into two integrals. For 3x squared, I'm going to rewrite this as 3 times the integral of x squared dx minus, and then for 2 over x squared, I'm going to take that 2 out, and then I'm going to flip x squared to become x to the negative 2 dx. All right. So there's our rewrite, which means we are ready to find the antiderivative. And both integrals will get power rule. So we get 3 times x to the 2 plus 1 over 2 plus 1 minus 2 times x to the negative 2 plus 1 over negative 2 plus 1. There it is. Clean up. 3 times x cubed over 3 minus 2 times x to the negative 1 over negative 1. Clean up some more. Your 3's will cancel. So you'll be left with x cubed. And then negative over negative makes positive. So I'll get positive 2 x to the negative 1 plus c. Cool. All right. Any questions on that page? These don't seem too bad, right?
No, not really.
Okay. Let's keep going. Let's see. Oh, sweet. All right, 15. The integral of 2x to the fourth minus x over x cubed dx. Again, we don't know how to find the antiderivative in this form, so we rewrite it algebraically. And we see that there's two terms over the same denominator, which means I get to rewrite it as two separate fractions. 2x to the fourth over x cubed minus x over x cubed. And then we're going to simplify these fractions. You get the integral of 2x to the fourth over x cubed. That just becomes 2x. And then minus x over x cubed becomes 1 over x squared. All right. And then let's go ahead and split this into two separate integrals. For the integral of 2x, I'm going to take that 2 out and multiply it by the integral of x dx minus the 1 over x squared. I'm going to rewrite as the integral of x to the negative 2 dx. Okay, these are all set. They're ready to go. We do power rule on both of these. So you get 2 times x to the 1 plus 1 over 1 plus 1 minus x to the negative 2 plus 1 over negative 2 plus 1. Okay. Clean up 2 times x squared over 2 minus x to the negative 1 over negative 1. Okay. And now your 2's will cancel. You'll be left with x squared. Negative over negative becomes positive. Positive x to the negative 1 plus c. There we go. Okay. And we're going to do the same thing for 16. All right. So again, two terms in the numerator, split them. Get the integral of x to the fifth over x to the fourth minus 2x over x to the fourth dx. Simplify, and x to the fifth over x to the fourth is x minus 2x over x to the fourth is 2 over x cubed. Okay. Now split into two different integrals. Integral of x dx minus, and now on 2 over x cubed, I'm going to take that 2 out. And I'm going to flip the x cubed, giving me x to the negative 3 dx. Okay. There's my integrals. They're set up. We can now find the antiderivative. Power rule on both of them. For x, you'll get x to the 1 plus 1 over 1 plus 1 minus 2 times x to the negative 3 plus 1 over negative 3 plus 1. Here you'll get x squared over 2 minus 2 times x to the negative 2 over negative 2. Final answer, I'm going to rewrite x squared over 2 as 1/2 x squared, and then negative 2 over negative 2 will cancel and become positive x to the negative 2 plus c. Yeehaw. Okay. Last one. Well, for these. 17, same exact thing that we did on the last two. Split it up into two separate fractions, simplify, find the antiderivative. So this will become the integral of x squared e to the x over x squared minus 2x over x squared dx. Then simplify, and your x squareds over here will cancel. So you'll just get e to the x minus, and then 2x over x squared, your x's will cancel and leave you with 2 over x dx. Okay. Split it into two integrals. You'll get the integral of e to the x dx minus, and for this 2 over x, I'm going to take the 2 out and leave it as 1 over x dx. Remember, we never flip those. Okay. We are now ready for the antiderivative. So the antiderivative of e to the x is e to the x minus 2 times the antiderivative of 1 over x, which is the natural log of the absolute value of x plus c. And there you have it. We have two application problems left, but those are all the antiderivative problems. Okay. So here's my caution. If you have the antiderivative of 1 over x dx and you decide to flip it, this means you will use power rule. So this will give you x to the negative 1 plus 1 over negative 1 plus 1. This will give you x to the 0th over 0. Well, what is any number raised to the 0th power?
1.
1. You get 1 over 0, which is what?
1.
Undefined. Can you ever have 0 in your denominator?
Nope.
No.
So do not make that mistake. That is why we never ever flip 1 over x. don't. That's it. Just don't. Okay. Any questions on this page or the previous ones? Still a lot of algebra involved, right? Okay. All right then. Word problem. Example 2. The marginal average cost of producing X sports watches is given by C bar prime of X equal to negative 1,000 over X squared. And here they're giving us a clue that C bar of 100 is 25. So we know that from 1324, C bar of X is the average cost in dollars. We need to find the average cost function and then find the cost function. So what they're giving us in this problem is the marginal average cost function. What we need to find is the average cost function. And in order to do that, we need to find the antiderivative. And then once we find the average cost function, we will be able to find the cost function. So we're going to go backwards, go backwards, go backwards. So let's start off by finding the average cost function first. So we'll call that A or 1. Find average cost, C bar of X. Okay, so in order to do that, we're going to set up the integral of C bar prime of X dx. And remember, this is C bar prime. So this is what we're going to plug in to the integral. You're going to get the integral of negative 1,000 over X squared dx. Okay, now let's go ahead and fix this integral algebraically before we find the antiderivative. So I'm going to take the negative 1,000 out, and then I'm going to flip the X squared to the numerator, making it X squared, X to negative 2 dx. Okay, we are now ready to find the antiderivative. And of course, we are using power rule. So you get negative 1,000 times X to negative 2 plus 1 over negative 2 plus 1. We get negative 1,000 times X to negative 1 over negative 1, which gives us negative over negative becomes positive. So you get 1,000
X to
X
negative 1
plus
C.
C. And there's part of our average cost function. We now need to solve for C to complete it. Okay. So now to find C. And we're going to use the clue given. Use C bar of 100 equal to 25. So what we know right now is that C bar of X is equal to 1,000 X to the negative 1 plus C. That's our average cost. Now using this clue, we're going to plug what number in for X?
25
Well, remember that's
or 100.
there you go. So you'll get C bar of 100 equal to 1,000 times 100 to the negative 1 plus C. Okay. But then the second part of the clue is, well, if C bar of 100 is 25, this means that this becomes 25. And 1,000 times 100 to the negative 1, which is the same as 1,000 divided 100, gives you 10 plus C. Move the 10 over, and we get 15 equals C. Which means that our average cost function is now 1,000 x to the negative 1 plus 15. All right. So we found the average cost function. We have completed the average cost function. Now we need to find the cost function. Find cost, C of x. Okay, so remember that the average cost function from the formula above, so average cost is given by the cost function over x. So this means that if I plug in the average cost function above, I have 1,000 x to the negative 1 plus 15. Okay. Well, what I'm going to do is put this, actually first, let me rewrite this. I'm going to say C of x over x is equal to 1,000 over x plus 15. So all I did was just flip that x down to the numerator. And now, in order to solve for this cost function, I'm going to multiply this x to the right side. So I'm going to multiply everything over here by x. I'll say I'm moving that over there, which means I'll get C of x equals, and if you distribute it to both terms here, you'll get 1,000 plus 15x. There it is. There's your cost function. Okay. And now the last part of the problem said, what is the fixed cost? What is the variable cost? So remember, in a cost function, you have a fixed and you have a variable. So from our cost function, the fixed cost is 1,000, and the variable cost is 15x. There you go. Not bad. Just a lot of going backwards. Any questions on that? All right then. Okay. Last one. Monthly sales of an SUV model are expected to increase at the rate of S prime of t equals negative 24 times t to the 1/3 SUVs per month, where t is time in months and S of t is the number of SUVs sold each month. The company plans to stop manufacturing this model when monthly sales reach 300 SUVs. if monthly sales now at t equals 0 are 1,200 SUVs, find S of t, and then how long will the company continue to manufacture this model? Okay. So we have to find S of t, but I want to label some clues that are given here. So we want to stop manufacturing this model when sales reach 300 SUVs. So one of our first clues is that we will stop sales when we reach 300 SUVs. The second clue given says that we start, so if time is 0, if at 0 months, we have 1,200 SUVs, which is right here. So this is another clue given. This says S of 0 gives me 1,200 SUVs. Okay, so those clues will come in later. Now let's find S of t. Find S of t. Okay, so that means we set up an integral. The integral of S prime of t dt. S prime of t is the problem or the equation given above. So plug that in. You get the integral of negative 24 t to the 1/3 dt. All right. Well, we can move the negative 24 out, but we know what's going to happen. We're going to power rule. So why not just move on to power rule already? That negative 24 will be outside, and you'll get t to the 1/3 plus 1 over 1/3 plus 1. Okay. And then you get negative 24 times, and 1/3 plus 1 becomes t to the 4/3 over 4/3. And of course, you will flip that. All right. Oh, I can start back over here. Okay. So you'll get negative 24 times, that 3 goes to the numerator, 3t to the 4/3 over 4. Okay. Simplify. That 4 becomes a 1. That 24 becomes a 6. Multiply straight across, and negative 6 times 3 gives you negative 18 t to the 4/3 plus c. All right. Here is S of t. Part of S of t, because still we have to solve for c. Which means we get to use one of our clues above. B, solve for c. Use that S of 0 is equal to 1,200. So our equation is S of t equals negative 18t to the 4/3 plus c. We're going to plug in 0 for every t. S of 0 equals negative 18, negative 18 times 0 to the 4/3 plus c. And remember that when S is at 0, you get 1,200. So this becomes 1,200 equal to 0 plus c. So C is just 1200, which means our equation for S of t is now negative 18 t to the 4/3 plus 1200. There we go. All right. And now we answer the last question. It says, all right, get different color. How long will the company continue to manufacture this model? So remember, we want to stop manufacture when we reach 300 SUVs. So now we're going to use the first clue. We are looking for time. So step C is solve for time. All right, and use that other clue. S of t equals 300. Okay, so I'm going to rewrite our equation, negative 18 t to the 4/3 plus 1200. And we are going to plug 300 in for all of S of t, not t, S of t. So you're going to get 300 equal to negative 18 t to the 4/3 plus 1200. All right. And all we have to do is solve for t. Move this 1200 to the left by subtracting, and you'll get negative 900 equals negative 18 t to the 4/3. And then divide by negative 18. And 900 over 18. 50. You'll get positive 50 equals t to the 4/3. Now, all we have to do is solve for t. So here's a nice little trick. To get rid of that 4/3, you are going to raise everything by the reciprocal power. So this means that I'm going to raise 50 to the 3/4. And I'm going to raise t to the 4/3 by the same exact thing. It's a pretty cool trick. So if you want to get rid of the power, raise everything by the reciprocal power. And the left side, you'll get 50 to the 3/4. But if you're typing it in your calculator, then just put it as 50 raised to the 0.75. And then on the right side, power to a power is multiplication. So this means that your powers will cancel. 4/3 times 3/4 just leaves you with t. It's beautiful. And then 50 to the 0.75 gives me 18.8 months equal to t. Now, depending on how picky my math lab is, hopefully it rounds it up to 19, but if it's even weirder, it might round it down to 18. So if we round up, 19 months. Boom. And that's it, y'all. Those are antiderivatives. More fun stuff to come.